In section 7.3, this is example 1, actually. I should put that in here. We've got two charges that are 30 centimeters apart. Charge A, charge B. Right now, A is positive. Let's put this in. So here's A. Over here is B. They are 30 centimeters apart. So this distance between them here, 30 centimeters. We know the magnitudes of the two charges. Calculate the net electric field 10 centimeters from A on the line connecting them. Okay, so let's imagine here's a line connecting them. They're 30 centimeters apart, so 10 centimeters is around here. 10 centimeters. That makes that 20 centimeters, according to my math. We're trying to find right here at this location, what is the net E field, E total, or sum of E? In order to know that, we're going to have to find out what is the E field due to A. So what E field does this guy have here? We're also going to have to say what E field does B have, so EB. We're going to find each of those things. Then we have to add them together as vectors because they are both vectors. All right, E field is KQ over R. I'm going to say QA here just to remind us it's this charge. We could say RA to say the distance away that we are. E field, let's see, the K value is always the same. It's this constant. This has nothing to do with springs, by the way, if it's the first time that I've talked about it. Nothing to do with the spring constant. This is Coulomb's constant, 9 times 10 to the 9. The Q value for A is 4 times 10 to the minus 9 coulombs. No signs are going in, so this guy's positive, it doesn't matter, but when we go to this guy, no signs. The R value is 10 centimeters, 0.10 meters. Don't forget to square it. Let's see, we do a little math. We get 3,600 newtons per coulomb. Now let's talk direction. I want to put a vector sign on here. I need to have a direction. Remember, E fields always point away from positive charges. Okay, so right here it's going to be pointing away that way. You could say over here it's going to point away, up here it's going to point away, down here. It's going to point away everywhere, but I only care right here. So it is to the right. That's an R there. We'll do the same procedure for this guy. We got QB over R. I'm going to say RB squared. K is 9 times 10 to the 9, always. Q value, 5.2 times 10 to the minus 9. And just note, no negative sign. We're going to do magnitude only when we sub these numbers in. R value, this R value here is 20 centimeters, 0.20 meters. Again, don't forget to square it. We'll do some of that math. We're going to get 1170. Now, big question here is the direction. Sometimes people will say, wait a sec, that guy's negative, it's got to point in the opposite direction. Remember, E fields point in towards negatives. Okay, so E field is pointing in this way, in this way, in this way. Over here, it is also pointing in that way. It is also to the right. Okay, so you could say they're in the opposite direction. This one's pointing away. This one is pointing towards. Those just happen to line up at this location. They're both in the same direction. So the sum of E fields is EA plus EB. They are vectors. We've got to treat them as vectors. This answer is going to be a vector. Sum of E, or E total, whatever you want to call this thing. We're going to say, let's say this direction is positive for our positive direction. So that's positive. It's to the right. This guy is positive, to the right. Sum of E is 4,770. Newtons per coulomb. To the right, let's do sig digs. I guess we have two sig digs. So sum of E is 4.8 times 10 to the 3 newtons per coulomb to the right. There's our final answer with some sig digs.